Right, so one of the nonlinear equations that you have to be familiar with is exponential growth, okay, or exponential functions. And exponential functions can be either growth or decay, okay, but their basic form is this: some constant times some base to some power. Okay. The idea is when if b is equal to 1 plus some interest rate in decimal form, you have a growth factor here. If b represents some value 1 minus an interest rate in terms of decimals, you have a decay factor. So the idea here is that a is your initial amount. Okay. So when you look at this, the initial amount is 388. So we know that a has to be 388. So once again, as a process of elimination, okay, you can eliminate a and b from your options. And so now you just have to see is, are we talking about, with this rate of 13%, 1 plus 0.13 or 1 minus 0.13? Okay, those are the two options you're looking at. Okay, so if it decays at a rate of 0.13, okay, that's our decay factor. We're looking at this quantity. 1 minus 0.13 is 0.87, and that allows us to answer choice D. Okay, so there is a strong possibility you have some kind of exponential growth or decay type of question on your SAT. Okay, in addition to working with these different types of equations, one of the things that you're going to be asked to do in the no calculator portion is to isolate variables in scientific or mathematical equations. Okay, so if you look at page 16 on question 15, I want you to see if you can answer this question. Again, scan the answer choices. That's my starting strategy for every question, because if you scan the answer choices here, you can tell automatically what you're looking to do. You're looking to solve for k. You can just see that. They're all k equals. So you don't really need to spend time reading the equations. It doesn't really matter for the sake of these problems what the variables represent. Okay? You just can jump to the idea that you need to solve for the variable k. All right, so go ahead, again, take a minute or two to work through that question. Right. One of the things when you are being asked to do calculations in the no calculator portion, one of the things that is somewhat consistent is you don't have to do crazy calculations. You shouldn't have to multiply 9 times negative 273. They're not expecting you to do that. So when you're working through a problem like this, keep things in sort of chunks or groups if it's going to be something that's more complex than just really basic mental calculations. So here, if I'm looking to isolate k, the first thing I would do is undo the adding and subtracting. So I get f minus 32 is equal to 9/5 times k minus 273. Now, if I distribute my 9/5, it becomes more complicated than I need it to be or want it to be without a calculator. So what I'm going to do is I'm going to undo this process right here. So I'm going to undo multiplying by 9/5. I'm going to do that by multiplying both sides of the equation by the reciprocal, 5/9. So now those cancel, and I get 5/9 times this whole thing. Once again, you're not being expected to distribute that out and figure out what those numbers are. Just leave it as in this form. And then the final step to isolate k is to add 273 to both sides. And so I get 5/9 times f minus 32 plus 273 as my solution, and that would be answer choice D. Okay. Now, if you are working with problems that look like they have like decimals, or let's say they have something like a 0.25, more than likely what you can do with decimals, if you're in a non-calculator portion and it requires you to actually distribute or multiply through, think of it in terms of its fraction form. Because if you think of it in terms of 1/4, more than likely this is going to be times something that has powers or multiples of 4 in it. And so it will make it easier for you to do it rather than leaving it in decimal form, change it to its fraction form. And that's pretty much with any decimals, if in the non-calculator portion. In calculator portion, just use the solve feature. Do you guys know how to get the solve feature on your calculators? If you have a problem where it's asking you to solve. Okay, in addition to isolating variables from different equations, you're also going to be expected to work with higher degree polynomials, and including adding, subtracting, multiplying, dividing, factoring. Okay, so this is on page 16 as well. And I want you to just really quickly see if you can work through this problem, please. And this problem is not an extremely challenging problem, but it does bring up a strategy that I try to emphasize, and that is work quickly. Right? You don't have to know the exact answer. You just have to know which of the answers is correct or which of the answers is not incorrect. So when I look at a problem like this, again, I scan the answer choices first. I see that this is just a straight combining polynomials, combining terms, but I notice that all my first terms are different. So do I need to know what k or the constant is in this problem? All I need to know is what the k squared coefficient is. So when I look at something like this, it says 7k minus the product of k plus 1 times 2k plus 2. Okay, so what I know is my k squared is I only have to FOIL this, the first part, the f part of FOIL, right? Because if I take k times 2k, I get negative 2k squared, right? And do I need to go any further? No. I have my answer choice B. It doesn't matter that you know or don't know the full answer. If you can identify which of the answers is correct, okay, then your job is done. You can move on to the next question. Does that kind of make sense? Look for shortcuts if you can. Once again, this is one of those strategies that's best practiced on the real, like the practice problems that they provide for you on either old tests or, again, if you find another site like Khan Academy or other College Board sites. Right. The next type of operation with polynomials, a similar kind of thing. Okay, this is on page 17. Okay, so once again, this is done with no calculator. So I want you to see if you can come up with the answer to this. Again, if you scan the answer choices, what do you notice about them? Does it tell you what kind of equation you're dealing with? Do you notice that they're all similar? Do they have similar parts? Okay, that's the best first approach to any question that I can, advice I can give. So on a problem like this, again, when you see the last term is either plus 1/2 or plus 3/2. Well, if I distribute this negative right here, minus a minus becomes a plus. I have 1 plus 1/2. So I know that my answer has to be plus 3/2. So I've eliminated 2 of the choices. Okay, the next thing would be my y's are either going to be a negative 1 over 88 or a positive 1 over 44. Well, if I see this as minus, let's put the 44s in terms of the same fraction, 88s. So this is 2 over 88. And now I can see 1 over 88 minus 2 over 88 leaves a negative. And so that would be my solution. Again, using that process of elimination is a very quick and easy way to approach problems when you notice the answer choices have some similarities. Right, the other type of operations with polynomials that you have to be able to do would be something like this. This is a little more complex of a question. Okay, it's on the same page 17. Okay, so I want you to approach this and see if you can come up with a solution. If you're uncertain of how to approach this, or even because there is a requirement to understand what it means for a function to be divisible by x, and if you don't quite remember what that is, anytime you have answer choices for all of your options, one of the things you could likely do is plug them into the problem. Even if you don't know what you're looking for, if you plug each of these numbers into the k value up here, and then expand those out and just compare what you get, it's possible that you might see one thing stands out as being different than the others. Okay? And so even if that comes down to where you've answered all the questions you can, you come back to this one, you still have a little bit of time. If you just plug these in for k, see what the expression winds up being, you might see there is one thing that's different. Okay? And if you see that one thing is different from the remaining, then that's going to be the solution that you would guess from. Now, the idea behind here is that if a function is divisible by x, what that means is there's no constant. The constant got canceled out or eliminated. So when you distribute this 3 here, and distribute this 5, so minus 5x minus a minus becomes plus 5k. What you can do is, in order for this whole thing to be divisible by x, you need to make sure that this portion that represents the constant is a 0, right? Otherwise, you can't divide by x. And so if you set 15 equal to 5k, you get your solution. Or not equal to 5k, but 15 plus 5k, that has to equal 0. Okay? And so if you solve for this, you can come up with your solution that k is equal to a negative 3. Now, if you plugged in each of these answers, or each of these answer choices to k in here, what you would find is when you write your expression, all of these have a plus some kind of constant out here. And this one's going to end with your x's. And so what that would tell you is this one is different. It doesn't end with a constant, so the one that's different would likely be the best choice to guess from. All right, let me jump to, or move on to the other thing that you need to be able to do with polynomials, okay, is to understand, again, the quadratic equations, parabolas. You can either expand this or treat it in the form that it's in, but I want you to take a moment, see on page 18, okay, how you would answer this particular question. So polynomials might be given as factors. They might be given as an expanded expression. Okay, so I mentioned this a couple days ago. Okay, with quadratics and talking about a vertex, okay, these are your 3 options for working through it. And you can convert any problem into any of these, okay, but if you know how to work with whatever the form it's given in, it might be an easy way to process this. This one is given in intercept form, so the idea is when you look at the graph of this, the value of x, it gives you a 0 for this first factor here. The furthest one on the right is negative 4. Okay, and the 0 for this factor, the value of x that makes this a 0 is 2. Okay, and so these are your intercepts. You don't know if this graph opens up or down, but you do know because they intercept right here, let's just assume it opens up. Because it opens here, the vertex is going to be halfway between this opening. So if you drew a vertical line halfway between those, so if you took negative 4 plus 2 divided by 2, that gives you your coordinate of negative 2 over 2 or negative 1. So you know on this one right here that your x coordinate is negative 1. Okay? Now it asks you what's the value of d. Okay? Well, we know that x is negative 1. To find the corresponding y coordinate, you simply take whatever you get for that value of x and you plug it back into your equation. So if I go back up to my equation right here, y of minus 1, in function notation, I'm plugging in a negative 1 for the x's. I get a times negative 1 minus 2 times negative 1 plus 4, and I get my solution here, a times a negative 3 times a positive 3, giving me 9a, negative 9a. Okay, and so that would be my solution for that value d, which represents the y coordinate of the vertex. Now, one of the other things that you can do when all the answer choices have a variable in it is you can assign a value to that variable and then evaluate the result. So here I could have let a equal any value that's easy to work with. So an easy number to work with would be 1. Okay, although sometimes one has properties that like will give it correct answers for multiple solutions. Okay, but you can always go back in and change that if the number you picked to start with didn't eliminate all but one choice. So if you just let A be 1 right here, what you can then do is identify if A is 1, you plug that in here as well as all your answer choices. Right? And so then you could identify, well, what would be the vertex if this was a 1? Okay? And so if this was a 1 and you went through the same process that we did down here, you'd get a -1 for x, -1 plus 4. And so here you would get this -3 times 3 equals -9. And you would look to see when you plug in the same number that you used here for A into each of these, which one gives you -9, and that would still be choice B. Okay, so you can just plug in numbers and test the possibilities regardless of that process. All right. In addition to understanding how polynomials and factors work in the factored form, you also need to know how they translate into tables. Okay, so this table right here allows you to see, allows you to understand, again, that when you're looking at factors like this, these factors correspond to zeros on an equation or on the graph of that equation. And so you want to be able to identify what has to be a 0 in order for that to be a factor. Right? So this is a question that kind of touches on that. It's on page 19. What you're being asked here is to determine which of these, so you're looking for factors of f of x. Okay? Factors of f of x provide zeros. Okay? Is the 0 a value where the x-coordinate is 0 or the y-coordinate is 0? Okay, if you think about when the x-coordinate is 0, that's called a y-intercept. When the y-coordinates are zeros, that's an x-intercept, and the x-intercepts correspond to factors. So the factor is x minus whatever the value of x is here that gives you that 0. So you know that the factor that corresponds to this 0 right here is x minus 8. And so that would be your solution. Okay, but to be able to interpret how factors correspond to the points on the graph, represented both on the graph and as in a table, okay, again, will be something potentially useful. All right, this next question is one that would be pretty late in a section. Okay, this is one that's pretty difficult for most students. Okay, so I want you to try it on your own. It's still on that same page 19. Okay, and then I'll talk through the strategy for it. All right, so I'm going to go through how to solve this 2 different ways. The first way, I'm going to show what I would do if I saw a problem like this. When I notice all of my answer choices have numbers, or have variables. Okay, so what I'm going to do is I'm just going to assign values to those variables. Okay, so I'm going to let A be something, and B be something. Well, which of these would be, so again, you can choose any values, but they need to fit this relationship. So the easiest thing for me to just randomly plug in here to be as consistent as possible would be what? Which letter can I pick a number for easiest? B, right? And I can let B equal? Just let it be 7. That gives me a very consistent one-to-one relationship here. So if B is a 7, then I have to choose what my A value is. So if A minus 7 equals 3, what does A then have to be? Good. And so if I just let that be, I can go in here and I can see which of these is a true statement. So is 10 plus 7 over 7 equal to 10 over 7? No, eliminate it. Is 10 over 7 equal to negative 4 over 7? Nope, eliminate. Is 10 over 7 equal to 7, or 10 over 7 equal to 10 over 7? Yes. Now, if this is the strategy you choose, it's not one that eliminates. Once you find that correct answer, that's not necessarily the only one that works. It is possible that there are values you chose that work in multiple variable or multiple answer choices. So if you do use this method, you have to test every single choice. If it winds up that you don't eliminate all of them, just pick a new set of numbers and retest it, and that should usually eliminate the other one. And so I do still, even though I found that this works, I need to test my last one. So 10 minus 14 over 7, does that equal negative 11 over 7? No. Once I eliminate all the others, then I know my solution.